everyone, welcome to the channel Question to Cure. This is the start of a medical research series where we explore large, complicated health science topics and break them down into small, bite-sized videos for any of us to learn to think like a researcher. Let's see what we have for today.
Imagine this. Two people are prescribed the same asthma inhaler, the same drug, the same dose, the same instructions. One of them can breathe properly for the first time in years, and the other feels absolutely nothing. Now, that is not a story about a bad drug. It is a story about a missing explanation, and chasing that missing explanation is the entire job. Which brings me to something that bothered me for a long time. The version of the scientific method we were all taught is frankly a lie. You know the poster all the science teachers have in their classrooms: observation, hypothesis, experiment, conclusion, 4 clean boxes, 1 arrow each, and you arrive at the truth. I believed that for years. Then I started reading how discoveries actually happened, and the line was never straight. It doubled back. It stalled. Experiments failed for boring reasons. It could be a contaminated sample, a broken freezer, and had to be run again. The poster isn't wrong exactly. It's just a summary written afterwards, once somebody already knows how the story ends. And here's the honest shape. You notice something odd. That gives you a question. The question gives you a guess, a hypothesis. You then design an experiment to test the guess, and you finally get data. And here's the part of the poster leaves out. The data almost never answers your question. It gives you a better question. Half the patients improved. Fine, but why those half? Are their genes different? Are they taking it at the wrong time of day? Is it even reaching their lungs? So you go round again and again. Science is actually a loop, not a ladder. You don't climb it and arrive. You circle a problem until it stops surprising you. Now, there's a distinction inside that loop that almost nobody outside science even knows about, and once you see it, you can't unsee it. There's exploratory research that casts a net. You don't know what you're looking for. You measure 1,000 things in 1,000 patients and see what patterns fall out. It's how you generate ideas. And then there's hypothesis-driven research, which does the opposite. You state one specific claim in advance. This inhaler fails in people with this particular airway receptor, and then you try your hardest to break it. Both are real science, but they answer different questions, and confusing them is one of the main ways studies mislead people. If you go fishing in a huge dataset and then report whatever you happened to catch as though you'd predicted it, that is not a test, that's a story dressed as a text. So what does a researcher actually do all day? Honestly, detective work. You've got an anomaly. Half the patients respond, you pin it to the board, then you pin up every suspect. Different genetics, different dose, different technique using the inhaler. Maybe they weren't taking it at all. And you go after them one at a time, ruling them out until the survivors are the ones that might be true. You don't start with an answer and defend it. You start with something that doesn't fit and you follow it wherever it goes. So if someone asks you what the scientific method is, don't recite the 6 boxes. Science isn't a checklist. It's a way of being wrong carefully, of setting things up so that when you're mistaken, the world can tell you, and you'll actually notice. The method isn't the poster on the classroom wall. It's the habit of letting the data argue back.
If you enjoyed this video, be sure to check out the rest of the series linked in the description below. Bye!